My name is Silvano Coriani. I'm a program manager in the Azure SQL team, where I'm looking after especially developer experience and the hyperscale platform. And that's why I'm super excited to talk to you about the new client development stack that we have for .NET. The idea behind this session is now that we have officially released the .NET 6. And there are some of the data access technologies that have been updated recently, specifically our SQL Client 4.0 and Entity Framework Core 6. So it makes sense to kind of show you some of the new features and new capabilities that we have been introducing in our client drivers and frameworks, and look at how this can help you building new and exciting applications for Azure SQL. So the agenda for the next kind of 60 minutes or such is to talk about what is new for these two client access tools and drivers. Specifically, we will focus on things like, for example, new configurable retry logic feature that we have in SQL Client in order to make your applications more resilient to kind of transient connectivity issues or blips that applications may encounter when talking to the backend database. And we will also talk specifically about features in Entity Framework Core 6, like, for example, the new temporal table support, the great improvements we had around performance, and we will see some do's and don'ts that are specific when you are developing against Azure SQL DB with Entity Framework Core, with some I hope interesting demos for you. So if we look at the what we call the SQL Server Experiences all up, right, we start, of course, from the SQL Server engine itself, which can be deployed in many different flavors, from bare metal to VMs, to, of course, our PaaS platforms like Azure SQL Database and Azure SQL Managed Instance. And on top of that, the entry door, I would say the front door of our engine are effectively drivers and libraries, right? Those are the kind of deliverables that developers can use in order to interact with the SQL Server engine. And on top of those drivers and libraries, there are a number of frameworks that have been built over the years. Things like, for example, DACFX for building the life cycle of your application, your database, or SMO to manage your existing services, and then CLI and scripting tools, notebooks, and graphical tools like the beloved SSMS or Azure Data Studio and so on, right? So but drivers and libraries are effectively the fundamentals of all this kind of higher level experience, and right now we have support for pretty much every operating system and every programming language. Right, and we are committed to make sure that our client drivers will provide the best kind of coverage of every new service and feature that we are introducing on the server side, in areas like, for example, programmability, security, performance management, and so on. So if we look at around the stack for all the different flavors that I was referring to from a SQL Server family perspective, we know SQL Server is speaking with this TDS protocol to the outside world, and for each of the various programming languages and operating systems, we have a combination of low-level drivers that are providing direct connectivity with the database server, and higher level programming frameworks, for example, Entity Framework Core or Hibernate in Java, SQLize for JavaScript, SQL Alchemy for Python, and so on and so forth. But what we are committed to as a Azure SQL product group is to make sure that whatever is your language of preference, whatever is the level of abstraction that you want to have, you have the right tool in place to talk to the SQL Server family of products, right? when it comes to .NET, and we will see specifically for .NET 6, but typically customers are embracing these three main options, right? If you want to be in control of every single kind of iteration between your application and your database, we have our Microsoft.Data.SqlClient classes that are providing abstractions and classes like SQL connection, SQL command, SQL data reader, again to control pretty much every aspect, every interaction between your app and your database. But sometimes we want to be a little bit more abstracted from these base constructs and capabilities, and we want to basically be more focused on application development productivity, right? This is where things like ORMs, so object relational mapping tools, are actually helping to find the right trade-off between productivity and control in our data access layer, right? And we typically have a choice between lightweight tools, like for example what are typically called micro ORMs, libraries and products like Dapper, for example, probably the most famous one, or ORM Lite, simple.data, and such, where the goal is to map your result sets into a collection of class instances or POCO objects in the fastest way possible, right? Simple, straightforward, but sometimes the fully featured ORM type of approach is the winning one, right? And this is where Entity Framework Core, that, as I said, we just released in version 6, is providing, we think, the best kind of trade-off between kind of performance, control, and productivity, as I was mentioning. Okay, let's talk about SQL clients. So some years ago, I think it's 3 years ago at this point, we actually released a brand new SQL client release called Microsoft.Data.SqlClient. This was basically outside of the full .NET framework and the various .NET framework releases as a standalone NuGet package or set of NuGet packages, actually. Right, and the goal for this is to be able to innovate as fast as possible from a client connectivity perspective to Azure SQL, and be able to release out of band and the faster kind of innovation possible for developers, right? So and we also open source this, and it's available on GitHub. You can find all the possible details here. You can install it via NuGet in your application, and it's effectively a replacement for the old system.data.SqlClient classes, right? The SQL connection, SQL command, SQL data readers are remaining the same and are almost fully compatible. There are some small differences between the two, but essentially this is the way we think the future for data access libraries for Azure SQL is going to be, right? Support across all the different kind of flavors, environment, operating systems, and such. As I was mentioning, we just released the V4 of this library I think a couple of weeks ago, right? And there are some interesting news. So first of all, we decided to turn on by default encryption. And this is, of course, super important from a security perspective. And, the reasoning behind this is that all our cloud efforts, all our cloud services are basically by default requiring encryption in client communications. So it's much simpler and easier now, which is true by default. At the same time, because we know we are also sometimes leveraging kind of things like local DB for local development on our own workstations. For local DB, there's an exception, and the client library is basically detecting when we are connecting locally and not requiring encryption, because kind of rarely encryption is set up for our local DB settings. One of the biggest, I think, achievements we had for the V4 is to have configurable retry logic fully GA'd. We will drill down into this feature later on, but effectively now is fully GA. There's no need for the safety switch that was previously required in order to enable this feature while in preview. And we also quickly kind of updated the error list of retriable errors to make sure that is as complete as possible. But as we will see, you can actually customize what errors to consider retriable and what's not in your own applications, right? Some other improvements were around mostly around performance for example, those commands that have a lot of parameters, right? There's a new a property called enable optimized parameter binding, which is recommended when you have lots of, specifically tens or even hundreds of parameters as part of your command. The other improvements are typically around data type support. So, for example, get field value async of T and get field value of T now supports things like XML readers, text readers, stream types. This is especially true when you are dealing with LOB, so line of business data types like varchar max and stuff like that to improve overall performance. There are also some, deprecations here. For example, we dropped the support for .NET Core 2.1 because it's now out of support at the end of life in terms of version. And there are also several improvements around always encrypted scenarios. So always encrypted is where you want basically from a client perspective to provide encryption keys as part of your connection to the database so that only clients with that particular encryption key provided can read specific data in your database, and no one else, including Microsoft or an attacker, can actually get access to the data in your database. Okay, let's drill a little bit into the configurable retry logic, right? So when we are developing distributed applications in the cloud, we know that transient errors, transient connectivity issues are a fact of life, right? So there are a number of reasons. We are not anymore in the situation where our application servers and our database servers are connected to the same physical switch. Here components, pieces of our applications are distributed everywhere, and it's important to consider that some of the database interactions that our application is having can fail, right? And one example is the same high availability architecture that Azure SQL is implementing, with the ability to fail over or to reconfigure a specific database to respond to, for example, an hardware failure, or this is effectively the way we can provide you 99.995% availability, because we can switch things behind the scenes. But as part of those kind of transient situations, applications may be trying to connect to the database, right? And usually what happens is if you don't have any application construct to deal with this transient situation, applications are just failing and getting back an exception, right? But maybe this reconfiguration period, for example, is just lasting few seconds. Typically, our availability architecture is responding between 2 to 8 seconds to one of those transient events, right? So what we can do in order to make our applications more reliable is typically to implement the well-known retry pattern, right? So intercepting whatever is the condition of error that has happened, understanding if it's a transient one, and then retry. In order to implement this, there are a number of packages and frameworks available out there. These are just few of them, and for different programming languages. For example, failsafe is for Java, Tenacity, Poly, and so on. But the reality is, developers are rarely implementing specific, retry logic capabilities in their own apps. So what we did was actually introduce some of these capabilities directly in the driver, right? So starting from the V3 preview of SQL Client, we have this retry capabilities available out of the box. Those for those capabilities works for existing apps, so there's no need to actually change your application. You just have to configure your app config file in order to buy into this retry framework, as we will see, right? And typically we manage two different conditions, right? One is when we are trying to open up a connection to the database and the database is not available for a short period of time, or while we are executing a command, right? So we have those two operations that we can basically configure as retriable, right? And we have baked into our SQL client driver a list of error conditions that we by default consider retriable from a Azure SQL perspective. Sometimes developers want to create their own lists of errors because maybe in a specific use case, even a lock, a database lock, which is preventing us to access a specific row, should be considered as transient, right? So for this reason, we open up, the ability to create your own error lists or to add specific error conditions to what the database is doing, right? So basically, this configurable retry logic is made of three main components. So there's a core API that application developers can rely on, can use, or can build their own retry logic providers against if they want to do something very special, right? And those behaviors that we have baked into the client driver are not enough for their reasons. And then we have this configuration file schema where again there's no need for actually use those APIs. You can just configure your client library, your SQL client components in your application to leverage the out-of-the-box retry capabilities, as we will see in a second. Right. So the core API is made of these three components. So retry provider is the higher level component here, class, which basically has a specific retry logic associated. Retry logic is the piece of business logic which is basically defining when the next retry is going to happen, based on our configuration details. And the enumerator is effectively the timer behind the scenes, which is generating the time intervals depending on the retry logic. But let's move to a more practical kind of section here, and how can we use this, right? So there are, I think, two major use cases here. One is I don't want to change my application code. I just want to enable retry capabilities for my connections and for my commands in the application, right? So I don't need to change my code. I just need to add an app config file with these sections defined in it, and specifying, for example, my retry logic details, like how many times I want to retry, what is the minimum amount of time, and how what is the profile, the retry profile, right? Or for example, for the SQL command retry logic, I can say, for example, only retry select operations, right? So this is a regex expression that says only commands that contain a select should be retriable, right? And then the list of errors in addition to the standard one, to the default one, that I want to consider as retriable. Okay, and of course there are a bunch of attributes that we have for the SQL connection and SQL commands. As we were saying, the number of retries, min and max, the list of transient error, the retry method, if we want to do a fixed interval type of retry, or an incremental or an exponential one. So wait, let's say 2 seconds, and then 4, and then 8, and such, right? Or basically none, So don't retry at all. This is, by the way, the default. If you don't specify anything, we are not retrying for you by definition, by default, but you have to specify one of these if you want the retry logic to kick in. If instead we want to get the most out of our retry logic, what we can do is we can write specific code leveraging those core APIs that I was referring to previously, and basically customize how our application is going to retry against a transient error the way we like, right? So the key here is this SQL retry logic option class. We can create an instance of this and basically define those max number of retries, the pattern that we are using, and so on. And then we are basically going to associate that retry logic to our SQL connections and SQL command. Right? That's what we need to do. And so let me show you something here. Here we are. Right, so this is a simple app, very, very simple one, where I'm just trying to open a connection against a database, right, and against an Azure SQL DB, and I'm just querying the version of my server. Very simple. There's no error handling, as you see here, and I'm retrying this every second. I also have a kind of a listener class here to show you some of the events that are happening, but the application is very simple. And in order to simulate a transient error, I'm actually using the firewall, the Azure SQL DB firewall. And right now I have no access to my database. As you can see here, I'm only allowing Windows Azure IP, but as I'm connecting from my own workstation at home, I don't have access to that database, right? So if I'm trying to run this as expected, I should get an exception here, right? And in fact, this is what I'm getting. So those are just the logging informations that I'm trying to open up a connection, and this is the exception that I'm getting. The exception is just saying that the client IP is not allowed, and specifically this is the 40615 error code in Azure SQL. Let's try to so what we can do here, I don't want to change my application code. This is an existing app, a legacy one that I'm just trying to make smarter in reacting to these transient errors. Right, so what I'm doing here, I'm just creating an app config file, and I'm renaming it right now because I have it ready, where I have these two sections, the SQL Configurable Retry Logic connection section and the SQL Configurable Retry Logic command. And what I'm doing here, I'm applying those two policies to all my SQL connection and SQL command code in my application, right? So as you can see here, what I'm doing, I'm just specifying as a retry method the fixed retry interval, right? So this is going to basically retry every 5 seconds for maximum 10 times. Okay, this is for the trying to opening up a connection, or same for trying to execute a command, right? And if I now try to execute this again, what we should see here is that the application is actually not failing anymore, right? So, and every few seconds, every 5 seconds specifically, is retrying up to 10 times, right? But if in the meantime, my error, my transient error goes away, like this, I'm just enabling my my firewall for my IP address, we should see here in a second, here we go, that now the application is working just fine, right? So without changing my application code, by just configuring my app config settings, I made my application resilient to transient errors in my cloud environment, right? So this is definitely a great one that we can rely on. Again, for applications that where we don't want to change, or we cannot just, for example, change the code. But let's see also what we can do instead if we are actually if we own the application code and we want to get the most out of this configurable retry logic, right? So from a code perspective, what we can do here is we can define our own retry logic parameters. So the number of retries, the kind of the interval mean and max, the transient errors that we are looking after, and then we basically are creating what retry method we want to use based on these options, and here we are creating a fixed retry interval. And then, next step is just to assign this provider that we created to the connection that we are trying to open. And, it's going to work exactly as we were seeing previously in the previous demo. The difference here is that, for example, as part of our application, we could create many different scenarios, many different use cases, and retry logic profiles, because, for example, we may have different different business requirements, right? For example, we may want all our transactions to always be retriable, or our select reporting operations to be always retriable, while if there is a more complex operation, we want to effectively the application to fail and log whatever exception the application was getting, right? But if we can modify the code, we can fully leverage what our configurable retry logic can offer here, right? So this is the way new applications can be developed, and in the spirit of a real cloud native app. For customers that really wants to do more, they can create their own logic provider. So in my previous demo, I was just leveraging the default out-of-the-box retry logic provider, which is providing those 4 retry methods, fixed, incremental, backoff, exponential backoff, and such. But there may be situations where customers want to do more, right? And create their own logic retry logic provider. So for those customers, my recommendation is to take a look at this example in our documentation, which is describing step by step how we can create basically a brand new retry logic provider, right? And in this case, this is just an example on how to do that. It's definitely not complex, but if you don't have special kind of requirements, I would definitely recommend you to stick to the out-of-the-box default provider that we have, right? So you may wonder, what are the key scenarios for this, right? So if I'm developing a brand new kind of cloud native data app leveraging Azure SQL, you definitely should consider relying on the configurable retry logic. This is very important in order to make your application more resilient to whatever is the kind of transit connectivity issues that is facing. Right? This will help significantly to achieve better resiliency in your app. For existing apps, for example, there's a migration from an on-premises application moved to the cloud. I cannot, change my code. Maybe I don't even have, the source code available, but I can still, by enabling the by configuring the app config file, I can still get some basic retry logic capabilities out of the box, and this again will help a lot customers. One specific example, subcase of this one is when you are, for example, targeting Azure SQL database serverless. We had a large customer that is embracing serverless with the ability to auto-pose backend database databases when they are not used. Well, the first time you will retry after the database went paused, and you will try, the applications will retry to access. The first reaction will be an exception, because the database will warm up, only after the first tentative of accessing it was executed, right? So for some existing applications, this behavior was definitely a no-go, right? And customer couldn't tolerate that the application were crashing while trying to access an auto-posed serverless database. Well, by adding configurable retry logic and just wait for those 30 to 60 seconds, that is the average ramp-up time for serverless, for auto-posed database in serverless, this customer was able to actually fully embrace serverless in their own solutions without requiring any application change, right? So super important for these kind of migration scenarios. So you can go ahead and look at the Configurable Retry Logic documentation that is available on docs.microsoft.com. You will see the link here in our slides. For those of you that are new to Azure SQL, I will definitely recommend you also this Azure SQL Fundamentals MS Learn course. It's really detailed, and you can start testing and experimenting for free with Azure SQL. And a free kind of sandbox ready for you. Also specific for scalability and reliability, I recommend you this well-architected framework, which is a series of best practices and kind of architecture guidance for building more reliable applications with Azure SQL, with Azure, I would say, overall. Okay. So let's switch gear to Entity Framework Core 6. So first of all, what is Entity Framework Core? For those of you that may not be familiar with, let me see if, okay, I can, sorry for, the animation here is not super precise, but basically Entity Framework Core, as I was mentioning, is a modern object relational mapper for .NET. It's basically taking your application entities, your application model, like your POCO classes and so on, and your database objects like tables and views and such, and it's bringing the two worlds together, right? And through this concept of a database context, context is taking care of mapping your application model, your application classes into database objects, and vice versa, and generating also the required code, to interface these two worlds, right? And application developers can use LINQ, right? So language integrated queries, so they don't need to specify SQL language to interact with the database, and the magic, the Entity Framework Core engine is taking care of things like managing updates whenever your entities in the application are changed. You can deal with schema migration for your model, basically driving changes in your database automatically, and also some degrees of abstraction from the underlying database, because Entity Framework Core is based on a concept of providers, database providers that can be switched, for example, from SQL Server to Postgres to MySQL without necessarily changing your application code, right? So basically, we have this concept of language integrated queries that, as I was saying, are programming language familiar type of way of interacting with objects in your database. You work with your natural domain objects, your POCO objects, customer orders and so on, instead of dealing with basically collection or property bags of data tables, right? Entity Framework can also aggregate a lot of single commands into a complex object graph and is basically implementing the kind of unit of work pattern and treating a bunch of operations as a single logical entity. Of course, in order to achieve this, we can configure all the basically interactions between our application entities and our database entities through a set of Fluent APIs or through kind of data annotation attributes. Right, and another interesting thing that Entity Framework Core is providing is the ability to handle concurrency out of the box. Right, so out of the box, you can change your entities at the application level, and the Entity Framework is detecting if the same entities have been changed already in the database while your application logic was working, and then you have to understand how to deal with concurrency, and for example, implement policies like the last change wins, or for example, just reload the new data in your application. And again, as I was saying, the ability to switch between potentially or to create more database agnostic applications by leveraging the various providers we have, right? And of course, dealing with database schema changes from an application perspective, so we can basically generate what we call migrations and apply those changes to your backend databases. Now, what is new with EF6 that we've just released? A lot of things, actually. A lot of them are specifically related to performance, but some are also related to provider-specific changes. For example, in SQL Server, we recently added support for temporal tables. Temporal tables are artifacts in SQL Server that basically can let you define, what is the period of validity of your data, and is basically taking care of managing the history of changes in your tables, and apply different, for example, storage policies to your current data and to your historical data. For example, you can create a clustered column store index on your historical data in order to get compression and to get a number of benefits in that sense, while your main kind of temporal table is optimized for data changes and for basically concurrency, right? Bunch of other changes are specific for, as I was saying, for performance. So I can show you some data points here on how performance were super focused for the Entity Framework Core team here. So there is a standard benchmark, an industry benchmark called Tech Empower Fortune middleware, where Entity Framework is used, and you can see here, in terms of requests per second. So the benchmark itself, it's open source. You can take a look in GitHub. Is providing some basic database interaction operations, right? So when you compare Entity Framework Core 5 on .NET 5 with EF6 on .NET 6, you can see that without changing anything else than just the the release of EF and .NET, you can get up to 92% improvements in terms of requests per second, which is pretty impressive, right? This is actually been kind of achieved on PostgreSQL, but it's the same from a framework improvement perspective. This is applicable to Azure SQL as well, and is a kind of a testimony of how the team has been working specifically around this. And compiled models is just one way of improving performance. A specific use case in terms of performance, which is the startup time. So the first time you are interacting with a model, with your application, database context, sorry, using normal models, depending on the size of your model, so the number of entities, the number of relationships and properties, and so on. Typically, there is the time to the first query is increasing in a kind of a linear form here, right? So the bigger is the model, and the higher is the startup time. And in some use case, I mean, this could be a server-side application where the first execution doesn't make a lot of sense, but generally speaking, improving this would provide great benefits in the life cycle of an application, right? So by optimizing, by pre-compiling your database model, your entity framework models through this command, so .NET EF, which is a .NET global tool, basically, and executing this .NET EF DB context optimize command, specifying what are the models that we want to optimize. The result that you get is pretty impressive, right? Because you can significantly kind of reduce here the trajectory of this line, and basically significantly reduce the startup time for your model, for models of all sizes, right, up to very large ones, and the result here is pretty significant. Okay, so let's take a look at entity framework and with some demos here, right? Okay, so I have a simple console application here where I have this again very simple database context. I just have two DB sets. These DB sets are basically representing database tables, if you will, right? And some configurations. And then I have these POCO classes here that represents my model. So I have one customer class with a bunch of attributes here. You can see it's a pretty decently wide one. And what I'm doing here in my application is I'm just basically querying my customers table, right? And I'm filtering out the customer table by name, right? And I want to extract all the customers that have this particular name here, right? And then with the toList, I'm effectively executing my query, and here I'm just looping on the results. Okay, so let's see. At the same time, I have here my SQL Server Management Studio, where I want to check, the kind of queries that are generated by my application. Right, this is a best practice that we should all adopt in order to check if our queries are effectively efficient and so on. Right, so the query here is executing, and I'm retrieving this customer ID 12 and Tailspin Toys here, right? So let's take a look at what's going on in my database here, right? So I'm here looking at my procedure cache to see what queries have been executed, right? So this is my query. How I know this is my query? Because in Entity Framework we can actually tag. We can close this one. We can actually tag our queries with some specific comments. This is very helpful because at the end of the day, you may generate hundreds of different queries, and you may want to, when you are investigating performance, you want to track where in your application logic this particular query was executed. So this tag with method is giving me the ability to add a comment in my query, which can be, for example, representing the name of the method where I'm executing this, or a particular scenario or use case, right? So, but if we look at this, this is the query text that have been generated for me by Entity Framework, right? And at the very end, we can see one interesting thing, right? This where clause that I have here, right, which is where customer name equals this string, it's been transformed as a Unicode parameter here. This n prefix means basically search, for Unicode strings like this, right? And if we look at the number of logical reads and the total worker time for a single query, this is pretty high, right? So if we look at, we can take a look at the query plan. And the query plan, what is telling us is that, well, first of all, these little arrows here are telling us that, this is a parallel plan. So more than one processor, more than one thread was involved. And we are not using, we are using an index, but we are scanning the entire index, right? So we are not basically seeking, leveraging the index to quickly retrieve our row here. And the reason is, the reason is explained here in this convert implicit message, where it's basically saying, hey, sorry, I was looking at the wrong one. There's an implicit type conversion here, because your table is varchar and your parameter is an n-varchar. So by default, entity framework because we are looking for a string, is basically associating that parameter to a Unicode string instead of a non-Unicode one, and is provoking this index scan. So how can we quickly fix that? Well, there are several ways of doing that. We can, for example, we could specify here an attribute for our customer name property, saying, hey, by the way, that data type is not Unicode, is a varchar. Or one smart thing to do that we can have now in Entity Framework 6 is to basically override the default convention, right? So by default, Entity Framework is treating all the strings as Unicode strings, right? So basically is mapping to n-varchar. If we do this, if we change, the conventions that Entity Framework is using to convert strings into something else, and we are saying basically convert all the strings to a varchar data type of maximum length of 250, right? And if we try to re-execute this, we can see that the string that we are now using. So first of all, of course, the result is the same, but what we can see here is that a new line has been generated here. The parameter is not n prefixed anymore, right? And if you look at the logical reads and the total worker time for executing this query, this is more than 100 times faster, right? And the reason is not scanning the entire index, is just looking at the B3 structure right now, and is efficiently retrieving the data, right? So this is just a small example, and that is telling us how it is important to understand how Entity Framework is generating our SQL code, right? And make sure that it is doing it properly, right? So here are some recommendations when we are dealing with modeling for Azure SQL DB. So make sure that you're using the right data types, you're using the right length of our, for example, string types, precision at scale, and such, because the result can be that, as we were saying, implicit conversion can lead to very inefficient index scans. We may want to generate a lot of different query plans for every query types if we, for example, don't apply a proper attributes or proper parameters, and basically by just controlling conventions and making sure that our code is designed properly, we can achieve much better performance overall. And we just quickly touched on the implicit conversion one in the demo, but this is the same for the other aspects. So Again, when we are dealing with Azure SQL DB, but this is true also for other engines, it's super important to push as much computation as possible to the server. Right? So avoid the client-side evaluation of queries that that Entity Framework can do. For example, if we have a method, a local method that we are using as part of our query, and the database server doesn't know anything about that method, Entity Framework needs to pull the entire set of rows from the backend table and then apply, the local predicate, and this is going to be very inefficient. Right, so make sure that we are always using, server-side evaluations as much as possible. Make sure that we are leveraging the right filters and projections. Right, only bring the data back that we need. In our example here, if I am enabling, this is another cool feature that we have, the ability to quickly turn on logging, right, with the log2 option in our Entity Framework model definition, right? So we can see here that if I'm re-executing the application now, you see a lot of things will get logged. We can see here that a lot of columns have been pulled out of the database, even if that's not required, right? So what we could do here, for example, is just to select, for example, only the fields that we need. So we could use select and say, hey, just create a new object for me, right? And can do, and here I can say ID equal, oops, sorry. So here we can only select, the fields that we actually need in our anonymous object here. And let me quickly. Right, so if we do this and we run the query again, and of course we need to select the right one, we will see that, our query here is going to be a lot more succinct. So see, only my 2 columns here have been retrieved. And if I look at, my query plan, here it is. So you can see we significantly cut in half basically the number of reads that we are doing in the database, and a lot faster kind of query execution time, right? So this is the kind of these are the kind of optimization that we always have to keep in mind, because if you are executing just one query, not a big deal, but if the application is executing hundreds of thousands of queries per minute, this can make a significant difference, right? One more thing here in terms of querying, by default, Entity Framework is tracking our, the data that we are reading out of the database, and is basically tracking this. We can see here in the logs, because basically you may need to record a change to your application objects, and then generate back the update query to your database. But in most cases that is not needed, right? So what we can do, we can turn explicitly off our query tracking behaviors here, and make sure that for all our queries where it's not needed, we are not going to track the object state, the entity state, while we are building up our model in Entity Framework, right? This is going to significantly save resources on your application tier. And again, performance is a critical part here of Entity Framework 6. First of all, it's super important to remember we always have to measure our database interactions. For example, there's a great framework called benchmark.net that everybody can use in order to measure their data access code performance, right? And is providing you all the infrastructure to run meaningful benchmark against your own data, against your own queries, right? And we just saw how to simply, turn on logging for troubleshooting complex or problematic queries. And when you think about performance, there are always, these 4 points to keep in mind, right? So first of all, your database or kind of optimization, so making sure that you have the right indexes, that you are using parameterized queries, and that your backend is efficient. Again, implement efficient projections and filtering, making sure that only the required amount of data is transferred between the server and your client app. Eliminate unnecessary round trips. This is also another interesting one I will show you in a second here. By default, Entity Framework is now implementing batching for all your database changes, and I can show you this. Here I'm just creating a bunch of records in my test table here, right? So it's 34 tables, right? And then I'm calling save changes. What Entity Framework is doing behind the scenes, we can actually see it right now, is basically taking all these new records entities that we have been creating, and is packing all of them in a single database interaction, right? So we can see here that, or just let me show you this in SQL, right? So this is the resulting query that we have. So it's basically creating a single query with a bunch of parameters here that are representing. Let me show you here. So that are representing those rows, right? So ID and value for my table, and it's just batching them into a single database call, which is much more efficient than doing 30 or X amount of round trips between the client and the server, right? So make sure that you are effectively leveraging these batching capabilities whenever you are implementing database interactions. And then we have seen, how things like compiled models, compiled queries are providing the best in terms of runtime performance, right? So we showed already a bunch of demos, but I encourage you to take a look at the links that I'm sharing here in the slides. Those are all about what's new in Entity Framework Core 6, and there are a lot of interesting aspects around modeling for SQL Server, for Azure SQL or SQL Server, and how to query data efficiently. And I think
thank you, Silvano. Thank you.
We
a
are
lot of
pretty much
exciting
it.
stuff, right? I mean, and I bet that good work means more work. So probably there is an entire roadmap ahead, right? I mean, what would be
Yeah,
some major milestones on the roadmap?
absolutely. So we just released actually the roadmap for Entity Framework 7, Entity Framework Core 7. It is public actually in our docs.microsoft.com, and you will see. So the major, I think, improvement that we are going to have in version 6 is the ability to support JSON payloads in our database tables, right? So we know that specifically for database engines like Postgres, but also for Azure SQL, the ability to ingest JSON data and to apply JSON functions on top of JSON data is super important. Think about scenarios like IoT, where typically ingested data are in JSON format, or even in your kind of RESTful scenarios, you are dealing with a lot of JSON fragments around. So providing full support for JSON data types and JSON functions in EF7 is going to be one of the greatest improvements we will have.
Excellent. I mean, support for various types of data is always good nowadays when we are actually managing all sorts of structured, semi-structured, and everything.